Hello, my name is Ilker Boz. I'm a research scientist at Virginia Transportation Research Council, a research division of Virginia Department of Transportation. In this presentation, I'm going to go over indirect tensile cracking test, a test that evaluates the cracking resistance of asphalt mixtures. This test is a part of a VDOT balanced mix design specification, and then we'll go into details here. VDOT spec requires that this test to be performed in accordance with ASTM D8225 standard test method for determination of cracking tolerance index of asphalt mixtures using indirect tensile cracking test at intermediate temperature. This test covers procedures for preparing, testing, and measuring asphalt mixture resistance at intermediate temperatures, and also covers determination of cracking tolerance index, CT index. This test method is intended to determine asphalt mixture cracking resistance at an intermediate temperature. And then also it's a part of VDOT requirement for balanced mix design procedure. The standard, ASTM standard, lists several apparatus to be able to perform this test. Many labs should have apparatus for specimen preparation process, which are not listed here, all of them. For example, you may need some ovens to prepare your specimens, but the main part that for testing itself is the loading apparatus and conditioning environment, whether that's an environmental chamber or water bath, with the following features here listed. Please check the standard for further details. And to note that the environmental chamber or water bath should be at 25 degrees Celsius. As part of VDOT balanced mix design spec, VDOT requires two sets of specimens to be tested under this test: laboratory mixed and laboratory compacted specimens, which is your design stage, and then field mix or plant mix and laboratory compacted, which is your production level testing. VDOT currently does not require any field core testing on this one. Also, spec requires 5 replicates specimens for testing under this method. Specimens have to be compacted to 7 plus minus 0.5% air weight content with a diameter of 150 millimeter and a height of 62 millimeter. Specimen preparation. For laboratory mixed and laboratory compacted specimens, specimens first should be short-term aged for 4 hours at the design compaction temperature prior to compacting. VDOT spec has a long-term aging requirement too for informational purposes only, but it requires long-term aging on specimens for 8 hours at 135 C after short-term aging. As part of this process, 5 specimens are required at a height of 62 millimeter and 7 plus minus 0.5% air void. So before testing the compacted specimens, specimens are needed to be conditioned at 25 plus minus 1 degree Celsius for 2 hours. And if using a water bath, specimens must remain dry during the conditioning process. For field mix or plant mix and laboratory compacted specimens, for short-term aging, you are going to avoid any aging there. Just bring this specimen to compaction temperature without any delay, and then compact immediately to the air void and specimen size requirements. For long-term aging, bring the loose mixture to 135 C and then condition for 8 hours at 135 C. You notice that there is no short-term aging here. Then compact the specimens to air void and specimen size requirements. Before testing again for this one, specimens have to be conditioned at 25 C for 2 hours. And again, if using water bath, specimens must remain dry. Testing procedure. Inspect the fixture to ensure that all contact surfaces are clean and free of debris. And install the specimens into fixture. Ensure that it is centered and making uniform contact on the support. And apply loading rate to the specimens at a 50 millimeter per minute rate until the load drops below 0.1 kilonewton after reaching the peak load. And testing shall be completed in 4 minutes or less after removal of the specimens from the conditioning environment. And once you have your data, each equipment or loading frame generates load versus displacement curve, as well as displacement versus time curve. So in this testing, no seat load is required, and a constant loading rate of 50 plus minus 2 millimeter per minute is required, and also load has to drop to 0.1 kilonewton or less. In the figures here, you see that compliant curves with respect to this test. And as you can see on the right figure here, displacement versus time curve, the slope of that curve should be 0.83. That will give you 50 plus minus 2 millimeter per minute loading rate. And I'm going to present some non-compliant data examples for your data quality checks. As you can see in this figure, load is, although it's indicated in kilonewton, it is in different units, perhaps in US customer units, and then load didn't drop to 0.1 kilonewton in this instance. So this is not a good data. So the test has to be repeated. And in here, some sort of glitch happened at the beginning of the test that it didn't record the displacement. And then also towards the end tail here, we see that probably the LVDT range is exceeded, therefore making this data is bad data, so the test has to be repeated for this case too. Another example here, what we have seen here, load is recording but not the displacement. Perhaps there is a synchronization issue with this, so machines have to be calibrated on a regular basis to prevent such errors with the test. And then once we test and once we check our data and they are good, we can proceed with the calculations. Here what we see, the equation of CT index. T is specimen thickness, GF is area under the curve normalized by specimen dimensions. I75 is the displacement at the slope. M75 is the slope at the post-peak of 75% load, peak load. And then D is specimen diameter. So most machines or all machines do that calculations automatically. And then once we determine our CT index, we are going to check this against VDOT BMD threshold, cracking index threshold for short-term age mixtures, and that is 70. And again, I have to emphasize that the CT index of 70 is for short-term age mixtures for VDOT spec. And if you have CT index of less than 70, that means that your mixture is crack susceptible and fails to meet VDOT spec requirement. If you have CT index 70 and higher, that means you have a crack resistance mixture and it passes VDOT requirement for this test. What about precision estimates? There's currently no precision estimates available for this test. However, at VTRC, we conducted a research and came up with a single operator variability of 20.7% using 5 replicates. And this hasn't been incorporated into spec yet, but it is expected to be in next year's spec. You have to check this as well in order for you to decide whether your mix is meeting VDOT requirements or not. In the next slide, I'm going to provide an example here. Again, all of the machines provide CT index automatically. You don't have to do this calculation by hand, but just in case, there's the equation, and then you determine the numbers from the load versus displacement curve, as well as your specimen dimensions, and plug and chug your numbers for CT index. What we hear here, a real example, 5 replicates from a mixture testing. As you can see, the average CT index 122.1, which passes CT index requirement, VDOT CT index requirement. However, when we look at this coefficient of variation, it is 28.2%. In this case, again, as of now, VDOT spec does not require single operator variability, but when it does, then you have to check that as well. In this case, although this CT index is a passing value, this mix is failing the coefficient of variation So it has to be repeated in that instance. With that, I conclude my presentation. Thank you for listening. If you have any questions, please email me at ilker.baz@vdot.virginia.gov. Thank you.